So today in this video we are going to see relationship between beta and gamma function. So the relationship between beta and gamma is given as beta of m comma n is equal to gamma of m into gamma of n divided by gamma of m plus n. So now we are going to prove this relation. For that we are just going to take the definition of gamma. So gamma of m is equal to 0 to infinity e power minus t to the power of n minus 1 into dt. So now I'm going to make some substitution in this. So I'm just going to take t is equal to x square. So when t is equal to x square, my gamma of m will be equal to integral. Instead of t, I'll be substituting minus x square. Here I have a t, so instead of t, I'll be substituting x square. And here I'm having a t. So instead of t square, it will be x square into m minus 1. So here I'm having dt. So here I have t. In order to get dt, I have to differentiate this t. So differentiating t, it will be dt. So when I differentiate dt with respect to x, when I'm differentiating t with respect to x, it will be 2x. Okay, so this will imply my dt is equal to 2x dx. So here instead of dt, that is instead of this dt, I'll be having 2x dx. Okay, now limits. So here this is limit for t is equal to 0 because my integration is with respect to t. So this is the point t is equal to 0 and t is equal to infinity. So I know that I've substituted t is equal to x square. So at t is equal to 0, at a point t is equal to 0, if t is equal to 0, x square will be obviously 0. So x will automatically be 0. So at t is equal to 0, my x is also 0. Now if my t is infinity, what will happen? If t is infinity means this is infinity. So x square will be infinity. So x automatically will be infinity. Okay. So now my limit for the interval will be t, that is my x now varies from 0 to infinity. So limits will be from 0 to infinity. Okay, so this is my gamma of n. So now I just simplify this. So this is 0 to infinity. 2 is a constant. I'm taking 2 outside. So 2 is outside. E power minus x square. X to the power of. Here you can see that I'm having x to the power of 1. And here it is 2m minus 1. That is, here I'm having 2m minus 2. This 2 is multiplied inside into x raised to 1. This x raised to 1 into dx. So this is equal to 2 into 0 to infinity e power minus x square. So now the powers can be added as they are in the product. So it is 2m minus 2 plus 1. Minus 2 plus 1 is minus 1 into dx. Okay, so remember your gamma of m under the substitution you can write it in this form. Later in the final step we'll be using this formula. So make a note of this formula. Your gamma of m is twice of 0 to infinity e power minus x square x to the power of 2m minus 1 dx is your gamma of n. So now if I'm writing another gamma of n, okay, just with a change of variable, will be 0 to infinity e power instead of x square. To show the difference, I'm taking it as e power minus y square y to the power of 2n minus 1 into dy. Okay, so now I have my gamma of m. With gamma of m, I have defined my gamma of n. So now gamma of m into gamma of n will be equal to, what I'm just trying to do is, I'm just going to prove this relation, right? So I'm just deriving my numerator part. So gamma of m into gamma of n. So now you can see here gamma of m into gamma of n means I can just write this. So it is 2 into 0 to infinity e power minus x square x to the power of 2m minus 1 into dx into integral 0 to infinity e power minus y square y to the power of 2n minus 1 into dy. Okay, so these two integrals I can combine and write. So the constants 2 into 2 is 4, 0 to infinity. This is also 0 to infinity. I just bring this integral front. So here I'll be having e power minus x square x to the power of 2m minus 1. Then I'll be having e power minus y square y to the power of 2n minus 1 dx dy. Okay, so now what I do is 4 into 0 to infinity, 0 to infinity. I combine this term and this term. So I can write this as e power minus, when I'm taking minus common, I'll be having x square plus y square. Okay, so the remaining term is x to the power of 2m minus 1, y to the power of 2n minus 1 dx dy. So now what I do is, to reduce the problem, I bring the transformation. This is in the Cartesian form. I take it to the polar form. So to take my gamma of m into gamma of n in polar form, what substitution I use is x is equal to r cos theta and y is equal to r sin theta. Under this substitution, what you'll have is dx into dy as r into d theta dr. Okay, and also you have your limits for your x and y. This is your limits for your x and y. When you are converting your x and y in terms of polar coordinates, in terms of r and theta, your dx and dy will be changed. So your limits also will be changed with respect to theta and r. Okay, so I'll just show you how this x, y are changed in terms of polar coordinates, but writing this directly will do. For your understanding part, I'm just going to derive it. Okay, so now we know that x is equal to r cos theta and y is equal to r sin theta. Okay, if I square this, I'll get x square is equal to r square cos square theta and y square is equal to r square sin square theta. So now if I want x square plus y square, if I add this, it will be r square cos square theta plus r square sin square theta. So this is nothing but both the terms are having r square common. So I'm taking that outside. It will be cos square theta plus sin square theta. So this is nothing but equal to r square. Okay, so x square plus y square is equal to r square. So now when I'm substituting here, I know what is x square plus y square. I know what is my x, I know what is my y. Now coming to dx dy. So dx dy is just derived from the Jacobian into dr theta. So how do you find the Jacobian? Jacobian of x comma y with respect to r comma theta. That is the Cartesian coordinate you are transforming into the polar coordinate. So the Jacobian is written by using the formula dou x by dou r, dou x by dou theta divided by dou y by dou r, dou y by dou theta. So dou x with respect to dou r. X with respect to r is cos theta. X with respect to theta is differentiation of cos is minus sine, so it is minus sine theta. Now y with respect to r, this is my y. When I differentiate this with respect to r, I get sine theta. Y with respect to theta, when I differentiate this with respect to theta, it will be r cos theta. So when I find the determinant value, it will be r cos square theta minus r sine square theta. So minus into minus will become plus. So it will be r cos square theta plus sine square theta when I take r as common outside. So cos square plus sine square is 1, so I get r. So my Jacobian value is r. So now I can write dx by dy is equal to r into dr d theta. Okay. So now my limits. Limit parts, if you see, you have limit like this 0 to infinity and 0 to infinity, and here you have some terms, it is into dx dy. So I'll show you. So you can see here. So the limit is from 0 to infinity, 0 to infinity, and the limits are for my x and y. So it is at a point, limits are for point x is equal to 0, y is equal to 0, and x is equal to infinity. That is, x varies from 0 to infinity and y varies from 0 to infinity. Okay, so now I'm just going to change my x and y limits to dr and d theta. Okay, this is converted into polar coordinates. So now if I'm having a graph like this, you can see that my x and y values are 0, 0. So this is the point where my x and y values are 0, 0. Okay, so now you can see here I have x square. You can see this, I have an equality x square plus y square is equal to r square. X square plus y square is equal to r square. I have one equality. From this r, I can write it as x square plus y square. Okay, why I'm writing this is I'm going to apply my limits for my r, and I'm going to apply my limits for my theta. So I have to get another equation with my x and y, which gives my theta. So I know that x is equal to r cos theta and y is equal to r sin theta. So if I divide y by x, I'll get r sin theta divided by r cos theta. So r and r will get cancelled. I'll be having y by x is equal to tan theta. Or I can write theta is equal to tan inverse of y by x. Okay, this is my theta value and this is my r value. So now if I'm applying the limits for my r, you can see that x and y varies from 0 to infinity. So now if x is equal to 0, that is for my lower limit. When my x is equal to 0 and y is equal to 0, my x is 0 and y is 0 means what will happen to my r? R also will become 0. Okay. So now when I'm applying the limits for my r and theta, you can see that when x is equal to 0 and y is equal to 0, the limits for my r also will become 0. Okay. Now when x is equal to infinity and y is equal to infinity, what will happen? Infinity square plus infinity square. So this also will become infinity. This is the limits for my r. Now coming to my theta. So you can see that again theta varies from 0 to infinity. For x and y, it varies from 0 to infinity. Okay, so where is the point 0, 0? So this is the point 0, 0. And it is given that x varies from 0 to infinity. So x will be varying in this direction from 0. Your x will be varying in this way. And y also will be varying from 0 to infinity. Okay, so it is varying in this direction. x in this direction towards infinity and y. So here you can see that this near axis, this is the point 0, comma 0. So it starts from 0 and you can see that the angle which it makes with the intersection point is 90, that is pi by 2. Okay, so your limits would be changing from 0 to infinity to 0 to infinity as 0 to infinity for r with respect to r, and for theta it is from 0 to pi by 2. Okay, so this is how it is being derived, but when you are writing for your exam, it is enough if you write x is equal to, in polar coordinate, x is equal to r cos theta, y is equal to r sin theta, then dx dy is equal to r dr d theta. Okay, along with this you have a substitution for x square plus y square. So x square plus y square is nothing but it is r square. Okay, so these substitution if you write it will do, but for your understanding part this part is given. Okay, so now I'm just going to rewrite what is my gamma of m into gamma of n. So gamma of m into gamma of n, which I wrote in the final step, was 4 into 0 to infinity, 0 to infinity, e power minus x square plus y square, x power 2m minus 1, y power 2n minus 1, dx dy. Okay, so now after this only we made the substitution. X is equal to r cos theta, y is equal to r sin theta, x square plus y square is equal to r square, and finally we have dx dy is equal to r into dr d theta. So all this we are just going to substitute in this integration. So now my gamma m into gamma n will be equal to this 4. I'm just going to split it and write it as 2 into 2. Okay, so first let it be as 2 into 2. Now, as I told you, the limits for my r will be from 0 to infinity, and the limits for my theta will be from 0 to pi by 2. Okay, so now e into, instead of x square plus y square, I substitute r square, e power minus r square. Okay, instead of x, I substitute x is r cos theta, so it is r cos theta to the power 2m minus 1, and instead of y I substitute r sin theta to the power of 2n minus 1, and instead of dx dy I'll substitute r into, first the inner limit is given for theta, so it should be written as d theta into dr. Okay, now what I do is I just split the r terms together and theta terms together. Okay, so while splitting this 2 also, I split separately for the r terms and for the theta terms. So first I split and write it for the r terms. So it is 2 into, the limit for r is 0 to infinity. Here I have e power minus r square, and here it is r to the power of 2m minus 1. Here it is r to the power of 2n minus 1 into r into dr. Okay, next all theta terms. So here again I have 1, 2 left out. So it will be 2 into 0 to pi by 2. I'm just going to write all terms with my theta. So it is cos to the power of 2 minus 1 into theta, sine to the power of 2n minus 1 into theta into d theta. Okay, so this is equal to 2 into 0 to infinity e power minus r square. So here you can see that the powers, it is 2m minus 1 plus 2n minus 1 into r to the power 1. So it's plus 1. So plus 1 and minus 1 will get cancelled. So here I have 2m plus 2n minus 1. So in 2m and 2n I can take 2 outside. So it can be written as 2m plus n minus 1. Okay. So r to the power of 2 into n plus n minus 1 into dr. Okay, and the second thing is 2 into 0 to pi by 2 cos to the power of 2n minus 1 theta sine to the power of 2n minus 1 theta into d theta. So this is gamma of m into gamma of n. Okay. So now, as I told you, when we call the very first definition I told you to remember. You can see that gamma of m can be written as twice of 0 to infinity e power minus x square. Here, if I'm having m, it should be 2m minus 1. You can see. So it's the same here. Here you have 2 0 to infinity e power minus r square. Instead of 2m minus 1, I'm having 2 into m plus n. So according to the definition of gamma, this can be written as gamma of m plus n. Because in the place of m in the equation which I showed, here I'm having m plus 1. And this, obviously we know this is the definition of our beta function. So beta of m comma n, I can write in this form. So totally gamma of m into gamma of my n is equal to gamma of m plus n into beta of m comma n. So now I just take all the gamma terms to one side. So gamma of m into gamma of n divided by gamma of m plus n is equal to beta of m comma n, which completes our proof. Thank you.